Okay, let's do some matrix math. Here we go. There's this math site. You can click on it. It's right here. A real-life example, bus and train. And this is what we're going to work through. And it just kind of shows you how matrix math is really powerful. It can do some fancy things. Here's our equation, x, our unknown number, and the matrix A must equal the matrix B. Well, with regular algebra, just to solve for x, you will isolate x, b divided by a, right there, b times a to minus 1. Well, to the minus 1 means the inverse, and here's the cool way to do inverses of matrices, and you get your answers, 16 children, 22 kids, 22 adults. So let's see how this program works. I click the button, and here we've got the information, how many children and adults. It prints out the inverse of the matrix, and then it calculates 16 children, 22 adults. Now, if you want to look at this, this is how you would solve it at high school using simultaneous equations, blah, 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 blah. This is how you'd solve it using the substitution technique, blah, 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 blah. And this is the information about taking a matrix. If your matrix is A, B, C, D, your inverse of the matrix is D, negative B, negative C, A. Everybody times that nasty thing of A times D minus B times C all over 1 or under 1. Okay, so the interesting stuff is the code. So let's go have a look. A reminder, ditch that if you're copying this to your to Notepad or some editor. Ditch that, see if it still runs with the latest version of TF.js, Tensorflowjs. What I've done in this is, as an extra, is I've extended a class. So the main class is tf.tensor. Notice the capital T. I've created my own class called myTensor because some examples I've seen, you have to adapt a class, or some of the examples write a class from scratch. So what happens is we've got a constructor with my temporary tensor, and the constructor starts right there and finishes right here, and the class finishes there. So this is an entire function with a dot naming scheme, my inverse 2D. It's an inline function, and then it does the math, and this is all just data sync, so it's slow. Math that you saw in those images of how to do an inverse. The matrix converted is 2D matrix where you're multiplying stuff. So this is solving it. It's returning the matrix converted, and then I've got the dispose function going on there. So that's just a side note. It's class definitions. It'll be a little bit different defining it. Instead of tf.tensor, we're actually writing new myTensor. Not even sure if I have to write the new. Remember, we normally do tf.small letter tensor. So this is just writing information to the div. We're doing div 333 this time. Setting up the first tensor. There's the information. There's the shape. The second tensor. There's the information. Doesn't need a shape. The result. Here we go, my own tensor. Oh, I started the my tensor is the new tensor. So here we go, my own tensor, my inverse 2-dimensional square, the my matrix original, that's that one. And then, looks like it's it for there. And then we take that result and we do a vector times matrix multiplication of my vector 1D, which is there, and the result of the inverse 1, which should get us our final answer. Okay? Not an enormous bit of code. There's the code. There's the class definition. And we got our results. 16 children, 22 adults, not using simultaneous equations, not using substitution. There's a subtraction technique. There's the substitution technique of simultaneous equations, where you have 2 equations and 2 unknowns and you're trying to solve for them. The matrix math version of it is a little bit sweeter to work with, but you're using matrices which are generally complex. Hope you enjoyed it.